So welcome. This is past paper questions based on related rates from calculus differentiation topic. So the first question is, a rocket is rising vertically at a speed of 300 meters per second. So rising height. So height is always denoted by h maybe. So we can take it as dh upon dt equals to 300 meters per second, where h is going to be the height. So you need to mention what is height. H is denoting height. Next, when it is 800 meters above the launch site. So h equals to nothing but how much? 800 meters. At a particular height, 800 meters, at that height, the height is increasing at a rate of 300 meters per second. Next, calculate the rate change in the distance. Distance is nothing but what we'll assume it as x. The variable that what am I using it out is x is going to be the distance. So x equals to, or he is asking us to find dx upon dt. Rate change means always with respect to time. And who is 600 meters from the launch site? The distance is going to be given as 600 meters. Now we know that it forms a right angle triangle. In a right angle triangle, we use Pythagorean theorem, x square, or rather than taking it as x square, what am I going to take it as? H square plus, because h is keep on changing, right? So variables, plus 600 square equals to nothing but what? X square. Distance of the rocket from the observer, we are assuming it as x. He is asking us to find it out. What is dx upon dt? So h square plus 600 square equals to x square. So what does that x becomes? X becomes square root of h square plus 360,000. Now dx upon dt is been asked. So I am going to find it out the derivative with respect to time. That is the easiest way. So dx upon dt. X derivative with respect to time is dx upon dt. Now this is root x. So remember that square root of x derivative so many times you'll be coming across. It is 1 upon 2 square root of x. Easiest way. So this is again 1 upon 2 square root of h square plus 360,000 times chain rule. H square derivative is 2h. Again h derivative is dh upon dt. So x derivative is dx upon dt and h derivative is dh upon dt. Now what am I going to do it out? I am going to plug in all the values whatever have been given. So 2 and 2 gets cancels. 1 upon square root of h is given as 800 square plus 360,000 times h is again 800 and dh upon dt has been given as 300. Simplify this directly. I am writing the answer. You should be able to get as 240. Don't forget to write the units. 240 meters per second. Coming to the question number 2. That one was question number 1. Now we go to question number 2. A ladder of length 10 meters on horizontal ground rests against a vertical wall. So we are going to take a right angle triangle again. This time the ladder is going to be the hypotenuse and the length of the ladder is 10 meters. So what are the variables over here? The variables are nothing but what? X, the height of the top of the ladder and the foot of the ladder. So this is x and y. So x denotes distance of bottom of ladder. Bottom of the ladder. And what does y denotes? Y denotes distance of the top of the ladder. Now again, so every time remember the variables should be considered. The variables are over here distance from the bottom and distance of the top. So again Pythagoras theorem, x square plus y square equals to 10 square. Then what else has been given? The bottom of the ladder is moved away from the wall at its constant speed of 0.5. So dx upon dt, because bottom we have taken it as x, dx upon dt is 0.5 meters per second. Calculate the speed of the descent. So y we are considering dy upon dt equals to question mark. Now x square derivative. What is x square derivative? 2x dx upon dt plus y square derivative 2y dy upon dt equals to 10 square. 10 square derivative is going to be 0. So I am writing it as 0. Now plug in the values. 2 times x value how much has been given? When x is 4 meters away from the wall. So 2 times 4 dx upon dt. What is dx upon dt value given? 0.5. 2 times y value. Do we know the y value? We don't know the y value. So therefore, we use the Pythagoras theorem, x square, which is 4 square plus y square equals to 10 square. So y square equals to 100 minus 16. So y equals to square root of 84. At that particular instant, the height is 84. So 2 times of square root of 84 and dy by dt you are supposed to find it out equals to 0. From here, we make dy by dt as a subject and negative 2 times 4 times 0.5 divided by 2 square root of 84. Simplify that, you should be getting it out minus 0.218 meters per second. This is the speed of the descent. So negative is already included. So therefore, what am I going to write it as? Whenever you're writing speed of descent, the negative symbol is already included. So you should be writing it as speed of descent equal to positive 0.218 meters per second. This is going to be the answer for question number 2. Now go to question number 3. Paint is being poured into a tray where it forms a circular pool. So there is a circular pool over here. We are pouring the paint. So obviously it will be taking the shape of a cylinder with a uniform thickness of 0.5. So thickness is 0.5 means the height is going to be 0.5. If the paint is poured at a constant rate of, so volume, we are talking about volume. So dV by dt equals to how much? 4 centimeter cube per second. Find the rate of increase of the radius. Dr upon dt equals to question mark when the radius of the circle is 20 centimeters. So radius equals to 20 centimeters. This is the data given. Now we know volume of a cylinder is pi r square h. This is a formula you need to remember, which is pi radius square. The height is given as 0.4. So the variable is nothing but what over here? Radius is the variable. So volume equals to nothing but how much? 0.5 pi r square. Now I am going to find it out. dV by dt is given and dr by dt is being asked. So directly find the derivative. So dV by dt equals to 0.5 pi, r square derivative is 2r. Then again r derivative is dr upon dt. So dV by dt how much has been given as? dV by dt is given as 4 equals to 0.2 times pi times 2 times radius. Radius how much has been given it as? 20 and dr upon dt. So 4 equals to 20 pi. Simplify that, it becomes dr upon dt. So what is dr upon dt becomes now? 4 upon 20 pi, which is 4 upon 20 pi is nothing but how much? 1 upon 5 pi. That's going to be the answer. So the radius is increasing because it is positive. It is increasing at a rate of 1 upon 5 pi centimeters per second. That was question number 3. Now go to question number 4. A lighthouse L is located offshore 500 meters from the nearest point P. So this distance is nothing but what? 500 meters on a long straight shoreline. The narrow beam of light from the lighthouse rotates at a constant rate of 8 pi. So this is an angle. It is keep on rotating. If at all the less angle is there, the light comes and hits over here. If at all it is a bit more angle, it hits. And if at all the angle is increasing, it is hitting in this way. So it is rotating at an angle of or at a rate of 8 pi radians per second. So d theta upon dt. The angle is 8 pi radians per minute. Calculate. See that you are using the exact units. Now, so this angle is going to be theta. Producing an illuminated spot S that moves along the shoreline. You may assume that the height of the lighthouse can be ignored and the beam light lies in the horizontal plane as defined by the sea level when S is 200. So we don't know at what point it is hitting. For example, we take it as the variable is X. So remember, always identify the variable over here. So I'm going to take tan theta. Tan theta equals to opposite side by adjacent side. So what do I get from there? X equals to 500 tan theta. Now x has been given as 2000, a special case. So if x is 2000, 2000 equals to 500 tan theta. From there, tan theta equals to 4. I do a bit part and do that. I find secant square theta because anyway I find the derivative of tan theta, which will be secant square theta. So therefore, I will be using and finding it out tan theta, secant square theta, which is 1 plus 4 square, which is 17. Now he's asking, show that the speed of s means dx upon dt. He's asking us to find dx upon dt. So dx upon dt. 500 is a constant, tan theta derivative. Tan theta derivative just now we learned secant square theta, and theta derivative is d theta upon dt. Now what am I going to do it out? I'm going to plug in these values. So which is going to be 500 times secant square theta is 17 times d theta by dt is 8 pi. Simplify this. I'm directly writing it as 214,000. What is that again? Meters per minute. That's going to be the answer. What is has been asked to prove. Find the acceleration of s. So once dx upon dt. So let me quickly add a page over here. We just now got dx upon dt. What was dx upon dt? We got that one was, we got 500 secant square theta d theta upon dt. This was the speed. This is nothing but what? Speed. Now it has been asked acceleration. If you find the derivative of this one with respect to time, then again it becomes acceleration, because derivative of velocity is acceleration. So d times d is d square x upon dt square equals to derivative of this one. 500 is a constant, d theta by dt is a constant, secant square theta, first power comes front, power minus 1, because it can be written as secant theta whole square. So power comes front, power minus 1. 2 minus 1 is 1. Then again chain rule, secant theta derivative. Secant theta derivative is secant theta tan theta. Again chain rule, theta derivative is d theta by dt. So remember, this d theta by dt is this one. And this d theta by dt is because of the chain rule. So there are two d theta by dt's. So I just mark it out, those two are same. Then another d theta by dt is because of the chain rule. Now what am I going to do? I'm just going to plug in 500 d theta by dt is 8 pi times 2 times, this is secant theta times secant theta is secant square theta, which was 17, tan theta was 4, and d theta by dt is 8 pi. Simplify this, I will be getting it out the answer as 43000 and 000, so which is 4.30 times 10 power 7 meter per minute square, because it is acceleration. That's question number 4. Now coming to question number 5. A straight first it is a 2 marks question, and this is very big question, which is a very wordy question. A clear diagram needs to be there with the variables, and do some calculus so that we will be able to easily understanding the solution. So what is he asking? A straight street of width 20 meters is bounded on its parallel sides by two vertical walls, which is 8 meter. One of them is 13 meters and another one is 8 meters. The intensity of light at a point P at ground level on the street is proportional to the angle theta APB. This is the angle APB. Find an expression in terms of for theta in terms of x, where x is the distance of P from the base of a height of wall 8 meters. So this is x. If this is x, then it has to be nothing but what? Another one has to be 20 minus x. That is x, and another one has to be 20 minus x. Now I want the angle for theta. So what am I going to do it is, this is alpha, this is beta. So tan alpha equals to 8 upon x. Tan alpha equals to 8 upon x. So alpha equals to tan inverse 8 upon x. Similarly, tan beta equals to 13 upon 20 minus x. Beta equals to tan inverse 13 upon 20 minus x, because we know that it is a straight line. This entire thing is a straight line. Sum of all angles in a straight line is going to be 180 degrees. Alpha plus theta plus beta equals to 180. So alpha is nothing but what? Tan inverse 8 upon x plus theta plus beta is nothing but what? Tan inverse 13 upon 20 minus x equals to how much? 180, which is pi. So theta equals to pi minus tan inverse 8 upon x minus tan inverse 13 upon 20 minus x. So that is the first part, right? Find the value. What is the thing is asking? Find an expression for theta in terms of x. That has been found it out. Calculate the theta when x equals to 0. So he is asking us to find it out. When x equals to 0. So what am I going to do that? I am plugging it out, value of x equals to 0. So instead of doing it out in this way, what I will do is, if x is 0, the denominator becomes 0. So the denominator becomes 0, which is somewhat, what is this? I'll write it out over here. Pi minus tan inverse of 8 upon 0 minus tan inverse of 13 upon 20. So this is undefined. Tan inverse of undefined is nothing but pi by 2. Pi by 2 minus tan inverse of 13 upon 20. So which is pi by 2 minus tan inverse of 13 upon 20. Now, what is this one? Now we should be knowing one simple formula. Tan inverse x plus cot inverse x equals to pi by 2. Tan inverse x plus cot inverse of x. Tan inverse of x of any angle plus cot inverse of any angle, the same angle, it will be equals to pi by 2. So I quickly add a page over here. So cot inverse x equals to pi by 2 minus tan inverse x. So we got pi by 2 minus tan inverse 13 by 20 will become pi by 2 minus tan inverse 13 upon 20 becomes cot inverse 13 upon 20. And cot and tan are reciprocal each other. So again it can be written as tan inverse of 20 upon 13. So when you do by calculator, it becomes 0.994. Cot inverse 13 upon 20 will become tan inverse 20 upon 13 because they are reciprocal to each other. Next part we have done. Find the value of theta when x equals to 20. The same thing once again. So what is that theta equals to? We got it out. Pi minus tan inverse of 8 upon x minus tan inverse of 13 upon 20 minus x. Now what are we going to do? X equals to 20. So it becomes pi minus tan inverse of 8 upon 20, then minus tan inverse of 13 upon 0. 13 upon 0 is pi by 2. So pi minus tan inverse of 8 upon 20 minus pi by 2. Pi minus pi by 2 is pi by 2 minus tan inverse of 8 upon 20. Pi minus tan inverse of 8 upon 20, just now we have learned, it becomes cot inverse of 8 upon 20. Again, cot inverse of 8 upon 20 has to be written in the form of tan inverse. You can do by calculator or else you can keep it as tan inverse 20 upon 8. Do by calculator, you will be getting it at 1.19. Next question, sketch the graph for theta between x equals to 0 to 20. So we have to draw the graph between 0 to 20. So what is happening for this graph? I draw the x-axis and y-axis. Now on x-axis I take 0, 5, 10, 15, 20. Now he is asking us to find the graph between for the theta value from 0 to for x 0 to 20. Theta value is from 0 to 20 and x. Now once it is 0, we come to know when x was 0, what was we come to know? It was 0.994. So 1 is over here, so 0.994 somewhere over there. Then when it is 20, it was 1.19. When it is 20, it is somewhere over here, 1.19. Now at 10, it will peak out. So because exactly at the middle, we come to know that because this is 20, so at 10, it will be exactly peaking it out. So therefore, what am I going to do? At 10, it will be the maximum one. So obviously, it will form a inverted parabola in this way. So let me draw properly again, joining all the 3 points. This will be the inverted parabola. Now what is the peak out value? X equals to 10. We can plug it out x equals to 10 and get that answer. Over here, what we can do it out is we can plug x equals to 10 and get that answer. As such, already I have done it out. I can keep it as 1.55. So which is theta equals to pi minus tan inverse of 8 upon 10 minus tan inverse of 13 upon 10. When you do by calculator, you should be able to get 1.55. That is all about nothing but what? 6c. Now 6d. Show that d theta by dx equals to such thing. So for this, let me add a new page and start it out. So what I get? Theta equals to pi minus tan inverse of 8 upon x minus tan inverse of 13 upon 20 minus x. Now from the formula booklet, tan inverse of x derivative. What is tan inverse of x derivative? 1 upon 1 plus x square. From the formula booklet, it will be there, tan inverse of x derivative 1 upon 1 plus x square. So now d theta upon dx. Pi derivative is 0 minus 1 upon 1 plus 8 upon x whole square. Now 8 upon x derivative minus 8 upon x derivative. So what does that becomes? It becomes minus 8 upon x square. Then again minus tan inverse of 13 upon 20 minus x derivative. So what does it becomes? 1 upon 1 plus 13 upon 20 minus x whole square. 13 upon 20 minus x whole square derivative is minus 13 upon 20 minus x whole square times minus 1. What am I doing it out over here? Why it is so much of confusion? So because what has happened is I memorized the formula for derivative of 1 upon x. Derivative of 1 upon x is minus 1 upon x square. Very simple. Okay, so 1 upon x derivative is nothing but what? Minus 1 upon x square. So 8 upon x derivative is minus 8 upon x square. 13 upon 20 minus x derivative is minus 13 upon 20 minus x whole square. But again chain rule, minus x derivative is minus 1. So let me once again do this. I know I went bit faster. So remember 1 upon x derivative is minus 1 upon x square. Then chain rule, again x derivative is 1. So pi derivative 0 minus 1 upon 1 plus 64 upon x square. 8 upon x derivative is minus 8 upon x square. Minus 1 upon x square. Then minus tan inverse of this one. So 1 upon 1 plus 13 upon 20 minus x whole square. 13 upon 20 minus x derivative is minus 30 upon 20 minus x whole square times negative 1. Now what does that becomes now? Minus times minus is plus 8 upon x square times 1 upon x square plus 64 upon x square, then minus 13 upon 20 minus x whole square times 1 upon 20 minus x whole square plus 169 divided by 20 minus x whole square. So simplify that one. It becomes 8 upon x square plus 64 minus 13 upon 20 minus x square, 20 minus x whole square gets cancelled. 13 upon, I'm directly writing 569 minus 40x plus x square. Simplify that. It becomes 8 times 569 minus 40x plus x square minus 13 times x square plus 64 divided by x square plus 64 times x square minus 40x plus 569. So directly I'm writing it out. You should be able to get 5 times 744 minus 64x minus x square upon x square plus 64 times x square minus 40x plus 569. This is going to be the answer. Now coming to the next part. That was a bit long question. Then, using the result in part D or otherwise, determine the value of x corresponding to maximum light intensity, giving your answer in 4 significant figures. So, maximum intensity means nothing but what we learned. First derivative should be equals to 0. So, again, and let me add a page over here. First derivative should be equals to 0. So, d theta by dx should be equals to 0. So, total denominator gets cancelled. So 744 minus 64x minus x square equals to 0. You can use the calculator, or this is a quadratic. You can factorize it out and get the value of x as I'm directly writing 10.05 meters. Factorize this quadratic, you should be able to get x value as 10.05 meters. That is part E. Part F. The point P moves across the street at a speed of 0.5 meters per second. Determine the rate change of theta with respect to time when P is at the midpoint of the street. So he has given that P is moving across the street at a speed of 0.5 meters per second. So dx upon dt is point F. Dx upon dt is 0.5 and x equals to nothing but what? 10. Now he is asking us to find it out. What is d theta by dt? D theta upon dt. So which is d theta upon dx times dx upon dt. So d theta upon dx is nothing but how much? We are going to find it out. D theta upon dx. I take d theta upon dx at x equals to 10. So plug in 10 over here. Plug in 10 over here. This is d theta upon dx. So plug in 10 over here. As such, already I have done it out. I am directly writing it out. Its value is 0.000453 times dx upon dt. What is dx upon dt? Which is 0.5. Simplify that, you should be getting 0.000227. Or if you want to write in the form of a fraction, 5 upon 22058 radians per second. Radians per second is going to be the answer. Now, because the video is becoming long, so therefore what am I going to do today? This is the last question, then we'll continue in the next part. A stachelostite has a shape of a circular cone. It is in the form of a cone. So volume of a cone, immediately formula 1 pi r upon 3 pi r square h. The height is 200 millimeters, and it increasing at a rate of, what is this, dh upon dt equals to 3 millimeters per century. Its radius is 40 millimeters and decreasing at 40 millimeters, not 400, 40 millimeters, and it is decreasing at a rate of, so dr by dt equals to nothing but what? Negative 0.5 millimeter per century. Determine if the volume is increasing or decreasing at the rate when the volume is changing and at which the volume is changing. So what am I going to do with it? I am going to find dV by dt. Then so pi upon 3 is a constant. It's a product rule. I keep radius as it is, r square as it is, h derivative is dh upon dt, uv prime plus vu prime. If u and v are there, product rule, uv prime plus vu prime. So r square times dh upon dt and h times r square derivative is 2r dr upon dt. Pi upon 3 r square h is the volume of the cone. Now what does that becomes? Pi upon 3, 2 times radius is 40. Is that radius is 40? Yes, 40 times dr upon dt. dr upon dt, so I do the substitution once again carefully. R square, what is the radius? 40. 40 square, dh upon dt is 3 plus h is nothing but what? 200 times 2 times r is 40 and dr upon dt. dr upon dt is negative 0.5. Simplify this. I am directly writing the answer. You will be getting minus 3200 pi upon 3, which is approximately equal to 3350 negative. So therefore, volume is decreasing at 3350 millimeter cube per century. That's going to be the answer. So we shall end it out over here, and in part 2 we do some more questions. See you in the next video. Bye.